Welcome to Lesson 7 of our Distance Learning series. For this lesson, you need a pencil and a blank page in your science journal or a blank Google document. You can title either one Distance Learning number 7. Look at the mouse on your screen. Is there anything unusual about it? If you said that it has no hair, you're right. But how did this happen? Why does this poor little mouse have no hair? A cool mini phenomenon. Having hair is a genetic trait. This means that the mouse was born with this trait. He didn't just one day lose all his hair. The hairless trait is encoded in the mouse's DNA. If we zoom into this mouse's cells, we can see that the DNA is contained in the nucleus. Remember earlier in the year when we investigated apples? We said DNA is the instructions to make proteins, and these proteins lead to traits. In most mice, the DNA makes proteins that give the mouse hair. But, you guessed it, this mouse has a change in its DNA, a mutation. This change leads to a new variation of mouse, one that doesn't have hair. In a moment, I'm going to read aloud an article so that we can gather evidence about mutations and their effects on organisms. If you prefer to read on your own, that's fine. Just pause the screencast and you can read right off the screen. As you listen or read on your own, think about mutations and how they can be helpful, harmful, or neutral to an organism. We're going to stop along the way to apply what we're learning to this hairless mouse phenomenon. Here we go. Some mutations have a negative effect on the organisms in which they occur. They are called harmful mutations. These result from random changes in a gene's DNA that makes proteins which do not function normally or may not function at all. For example, imagine a population of white Arctic hares, those are like rabbits, that get a random mutation changing their hair color to tan. This mutation is harmful since they no longer blend into their snowy environment and become targets for predators. Some other harmful mutations you may be familiar with can lead to genetic disorders or cancer. A genetic disorder is a disease caused by a mutation in one or a few genes. One example is sickle cell anemia, a disease in which there's an incorrect protein which causes misshapen blood cells which are now unable to carry oxygen around the body. Cancer is another disease in which cells grow out of control and form abnormal masses known as tumors. It's generally caused by mutations in genes that regulate how cells divide. The mutated cells have damaged DNA and divide without limits. Cancer genes can be inherited, or they can occur naturally, or cancer can be caused by environmental factors. Now, let's apply what we just read to this hairless mouse phenomenon. Could you think of an environmental situation that would cause a hairless mouse to be least adapted? In other words, cause a harmful mutation that limits the mouse's survival. Take a moment to write this down in your science journal or on your Google document. Okay, let's continue reading. Remember, if you prefer to read on your own, you could just pause and read on your own. Some DNA changes have a positive effect on the organism in which they occur. These beneficial changes are called helpful mutations. They lead to new versions of proteins that actually help the organism adapt to changes in their environment. For example, remember that population of white Arctic hares? You can see them right here. Let's view their mutation through a different lens. Global warming has the potential to eliminate snow, leaving some areas of bare brown ground exposed. If the hares with a tan mutation are living in this area, they will survive as they blend into this new environment. This mutation actually increases the tan hare's chances of surviving or reproducing so that the tan hare will become more common over time. When considering whether a mutation is helpful or harmful, you really have to take the environment into account. Beneficial mutations are essential for natural selection to occur. They increase an organism's chances of surviving and reproducing, so they're likely to become more common over time. And there's several well-known examples of this. One of those really well-known examples has to do with mutations in bacteria. These mutations allow the bacteria to survive in the presence of antibiotic drugs, and the mutations lead to antibiotic-resistant strains of bacteria that don't die in the presence of these medications. The same is actually true for viruses. Viruses have genetic material which can mutate and change certain characteristics, enabling them to easily spread and infect other living organisms. Okay, take what we just read. Under what environmental conditions can this hairless mouse, this trait, be considered a helpful mutation? Come up with an environmental situation in which this would be possible. Write it in your science journal now or on your blank Google Doc. On to our last section of reading. The majority of mutations are neutral in effect. That is, they don't have either a positive or negative effect on the survival of the organism. Neutral mutations can happen in two ways. The first way is that sometimes mutations in coding regions are repaired before they can cause any changes in making proteins. But secondly, not all of our DNA codes for proteins. Scientists refer to these non-coding regions as junk DNA. If a mutation occurs in these regions, there is no change to the organism since that region of DNA wasn't making any proteins. Okay, take what you just read and apply it to this situation. If this hairless mutation was in fact a neutral mutation, would the mouse even look hairless like he does in the picture? It's time to see what everyone thinks about the hairless mouse. Now, even though our class isn't meeting together in one room, that doesn't mean our discussions have to stop. I think it's important to have some interaction with your classmates to help move our science thinking forward. It'll also give us a chance to test out the discussion board on Schoology for future lessons. So, using the discussion board, you're actually going to discuss the environmental conditions that could help or hurt the survival of the hairless mouse. In other words, when would the mutation be helpful or harmful? You'll need to post a response justifying your thoughts and then respond to at least one classmate. All the directions are listed under today's Schoology folder. Let's keep our talk productive and respectful. I have some prompts listed on the screen that can help you with this. When you respond to a peer, you may want to say things like, I want to add on to what you just said. Or you make a good point when you say, or have you considered this? Until tomorrow, I need you to keep thinking and keep learning.